Hello and welcome to ATI 4205. This session will address equipment and technologies used to support production logistics. In addition, it will address capacity planning and the need to design an effective capacity. The session will end by defining bottlenecks and identifying ways to reduce these bottlenecks and increase efficiency. The decision to select the proper equipment and technology is hard and complex decision. It will be based on several factors such as cost, quality, cash flow, capacity, flexibility, market stability. Even if you want to buy one of the equipment, you need to see if it fits exactly in the spot that you need in the factory, on the production line. You need to see if you have enough space to add any equipment, any type of equipment. And when you do that, you need to look at the cost, you need to look at the quality, you need to look at capacity, how much would it produce per hour. So all these are factors that you need to study before you select or you take any decision about this kind of technology or the equipment that you need in a factory. Technologies will increase efficiency, quality, and flexibility. It will actually reduce cost, processing speed, and customer response time. You want the processing speed to be less. You want it to be faster. And you need to respond to customers as fast as possible. When they put an order, you need to send it as soon as possible. So you need some kind of technologies that will increase the flexibility and reduce the processing speed and reduce response time to customer. Some of the production technologies that can be used are machine technology, automatic identification systems, process control, vision system, robots, automated storage and retrieval systems, flexible manufacturing systems, computer-aided integrated manufacturing systems. And we'll talk about each one of them individually. The use of machine technology increased precision, productivity, and flexibility. It reduces environmental impact. It supports innovative product design, minimal custom tooling required, minimal assembly time, low inventory, and reduced time to market. Some of the well-known used machines technologies are computer numerical control, which is CNC machining, and additive manufacturing, which is adding material layer by layer. The additive manufacturing supports innovative product design, minimal custom tooling required, minimal assembly time, low inventory, and reduced time to market. When you need any item, you can produce it on the spot. You can print it, 3D print it on the spot, so you don't have to have inventory since you are printing it as you go. The automatic identification systems and the use of radio frequency IDs, identification ways, improved data acquisition and reduced data entry errors. Since all items can be scanned electronically by the system, that increased the speed of item tracking and the ability to improve many processes. As soon as it passes through a certain point, it can be scanned, and when it scans, then you know that this item is in this stage or this spot. You can track the item as it moves from one process to another. In addition, if it goes to inventory, it will be scanned and you can track it in inventory until it's been shipped, or if it needs to be reprocessed or used again. The process control, which is real-time monitoring and control of processes, increased process stability and increased process precision. It gave real-time provision of information for process evaluation and made data available in many forms such as charts, figures, diagrams, and reports. We can add on the line, on the production line, we can add cameras, we can add sensors, we can add any type of machine that will assist me in collecting data and informing me of what's going on the line. Not only that, all that data will go to a server, and the server can generate for me a software. I have a software that will generate for me charts, figures, diagrams, and reports as needed. This is a screenshot of software that controls the process control software dashboard, and from that dashboard you can see from that screenshot it shows alerts, charts, gauges, figures, and reports. The manager can monitor factory operations and processes using these screens. If you have more than one monitor in front of you, then you can see all these activities, and based on that you can see if there are anything that is wrong or anything that should be adjusted, and you can adjust it from the screen. You don't even have to go to the that machine or to that area. Even if you want, you can either send someone and tell them to adjust, or you can go yourself, and that will take a few minutes because you know exactly what's going on and you know the proper configuration to adjust to. Vision system aids in inspection. It will assist in production orientation and the position accuracy. With the current advancement in technology, cameras can be installed now with a modest cost, with even cheap cost. These systems are superior to people performing the same task. They can stay overnight, they can stay all time, at any time, any condition, in any place. Those small cameras can be installed near stove, oven, and you can make sure that they are isolated with something for the heat, so it will not be affected. You can also monitor small areas that the human cannot get to. If it's very narrow area and very small area, it can monitor at night with night vision. It will have zoom in if you want to zoom in. So all these vision systems actually assist more in the accuracy. And you will have sensors attached to these cameras, so you will know the dimensions of the box, if it is in the right position and right orientation, and you can twist it, you can move it until it's adjusted to scale. Robots perform monotonous or dangerous tasks. Robots can perform tasks requiring significant strength or endurance, such as the robotic used to car assembly. It can hold the body of the car or the chassis, or it can hold the engine with no problem and mount it in. So all these robots can hold big weights. It can it will have big strength to move stuff from one place to another. The robotic arms provide consistency and accuracy, especially in welding, pressing, cutting, milling, and drilling. And again, you know, if it's configured, if it's connected to a computer program, then it will do the job for you without the need to worry about the precise welding or precise cutting, because already it is within the configuration of that robotic arm. I added for you a few videos that will show you different functions that's been used, that uses robotics or robotic arms to do a process between palletizing, flipping boxes, flipping parts using different technology. We have also universal robotics arms, UR10. They have 3, 5, and 10. It depends on the size of the robot that you are going to use and the space for it. And we have also the automotive industry robots. So look at these videos, and you will see how each one of these robots being used in technology or in manufacturing or production. Automated storage and retrieval system. We talked about these systems before in an inventory or in a warehouse, which is the same here. A factory will have its own inventory. So having such a system will assist in getting the parts from the place they were stored in and all the way to the manufacturing area or the manufacturing firm without any errors or with reduced errors. So this is what we are trying to do. We are trying to use machines to retrieve the parts and bring it to the production line. And this is one of the systems that can be used, although we are saying that it can be used in a warehouse, but also it can be used in the inventory of a manufacturing facility or a production facility. The automated guided vehicle, also something that we talked about before, in the warehouse, which is electronically guided and controlled carts used for moving or the movement of products and or individuals, which is that's another technology that plays a huge factor in improving processes and increasing efficiency within a factory and within the warehouse and inventory management system. The flexible manufacturing systems computer controls both the workstation and the material handling equipment. The FMS can enhance flexibility and reduce waste. It can economically produce low volume at high quality. It can or it reduces changeover time and increased utilization. It has strict communication requirement between the components. And again, you know, if you click on the video, you can watch the flexible manufacturing systems.
Typically, at workday's end, machines shut down, people leave, and you're left with unused production capacity. This, along with other factors, reduces machine utilization rates, resulting in a great deal of unused potential. Fortunately, there is a solution. Fastum's FMS, Flexible Manufacturing System. Fastum's solution incorporates the machine tools you choose and uses engineered modular components to fit into your factory and precisely meet your needs. In this pallet-based automation system, the pallets and parts are efficiently stored and organized in a minimal footprint that saves floor space.
So you can complete the video and see how this video addresses the palletization and the putting on the shelf material. And again, that's flexible manufacturing system that's been computerized or that's been controlled through programs to do the stuff that we need. Computer integrated manufacturing, or CIM, is an extension of flexible manufacturing systems. It extends process improvement all the way back to the engineering process and inventory control. It also went forward all the way to warehousing and shipping. It can also include financial and customer service areas. Computer integrated manufacturing reduced the distinction between low volume and high variety and high volume low variety production. Through the ability to change configuration using dashboards and touch screens. Capacity is the throughput or the number of units a facility can hold, receive, store, or produce in a period of time. Looking at the definition, we recognize some of the reasons why capacity is an issue. For example, the capacity can determine fixed costs, the cost that will be required to build and deliver the product. Some of the fixed cost examples will be addressed at a later slide. Also, it can determine if demand will be satisfied, which means it can measure the capacity required for a production facility to meet market needs. For example, even in service, if you don't have enough capacity to handle the number of customers that's coming to a certain facility, that will be a problem with the capacity. We are talking about patient in a hospital. If the number of ICUs in a hospital is limited, then if you have any problem like a pandemic and you have increased number of people, the hospital will not be able to meet the demand of the community because of its limited capacity. So the capacity of the hospital needs to meet the demand of that community. The same for other production or other areas, from manufacturing to services to other areas. Always we need to look at the demand, and we need to look at the capacity that we have in the system. Can we fulfill the demand or not, and what can be done to increase efficiency. Usually we design capacity to be maximum theoretical output of a system expressed in rate, but most of the time capacity maximum cannot be reached. Although they can ship for you a machine that can do, let's assume, 100 units per hour, that is the maximum, but it might not reach to 100 units per hour. Then how could it be done? The company or the firm must define and measure their own capacity. The effective capacity will be the capacity of a firm that will be expected to achieve given current operation constraints. The company needs to look at their limitation and constraints, which often lower that design capacity. While a process may have maximum capacity, many factors prevent us from achieving that capacity. Based on the definition of both design capacity and effective capacity, we can define and calculate utilization and efficiency of the machines. Utilization is the percent of design capacity achieved, which is equal to actual output divided by design capacity, while efficiency is the percent of effective capacity achieved, which equal to the actual output divided by effective capacity. When planning for capacity, the company must forecast demand accurately. Decisions could be made to fulfill demand through subcontractors and adding shifts instead of expansions and adding new machines until the company is sure of the constant increase of demand. At that point, the company will match technology increments to the sales volume. An optimum operating size can be determined, but at the same time the capacity will be built with room for change, increasing or decreasing. To manage and fulfill demand, we need to compare the company's capacity with the market customer demand. There are three different scenarios. Demand might exceed capacity, capacity might exceed demand, and we might have a demand that will depend on the season affected by planning for capacity. If demand exceeds capacity, then we can control or reduce demand by raising prices, scheduling longer lead time, or as long-term solution, the company can increase capacity. If capacity exceeds demand, the market can be simulated through price reduction and aggressive marketing. At that point, the company can also make some changes to attract customer through adding additional features and specs to the product. If the demand is seasonal, we can use modules to produce products that will fit with little adjustment into the different seasons. For example, snowmobile in the winter, jet ski in the summer. We can use some of the parts from here, and then we change it from a snowmobile to a jet ski, or from a jet ski to a snowmobile. It depends on the season that we are dealing with. So most of these components are the same. We can standardize it, we can make it consistent, and a few adjustments will be made between the two products to fit the different seasons. Some of the tactics that can be used to match capacity to determine or to demand is to hire more personnel and or purchase additional equipment to increase capacity. And for that, capacity and selling or leasing existing equipment to decrease capacity. So we can also analyze current processes and have a continuous improve process in place to increase throughput. So again, we need to make sure that we are matching capacity to demand. To do that, we can bring more people and maybe more equipment, maybe increase the number of production lines. If we have one line, we can double it. We can make 2 production lines or 3 production lines. It depends on the demand. But sometimes this will not be the solution, because at a certain point, if that production line was not utilized to its capacity, then that's a problem. But at the same time, there are some people that will use it for a while and then they will sell or lease it to other companies. And it's very, very important to understand exactly what's going on with the current processes, and if we need to increase the throughput, or we need to redesign the product to facilitate more throughput through using modular design, or changing the material used, or any other design related options. When creating different product related processes, a flexibility should be added to each process to meet any future change or any design changes. If the capacity still exceeds demand, the company can resort to the last option or tactic by closing some facilities. Monitoring production is used to follow up with discrepancies in the production plan and to identify bottlenecks. Monitoring will identify problems before they happen. Monitoring will report issues as opportunities for improvement. Looking at the production system, each work area or workstation can have its own unique capacity. The capacity of one workstation can affect the capacity of the whole system. To determine the throughput capacity of workstations, we can conduct capacity analysis. The workstation that has the most limiting factor or constraint is called bottleneck. We can identify the time to process an item through each station. The total time to produce one unit will be called, or is called, process time. Identifying bottlenecks in manufacturing is usually easy. On an assembly line, you see when products pile up at a certain point, and tools that can be used to identify bottlenecks can be the flowcharts and the 5 ways techniques. And we did look at flowcharts before, or other charts that we used or explained in the first session of this topic or this chapter. That can be used to identify these bottlenecks or these problems in the process. You have 2 basic options for unblocking your bottleneck. Either increase the efficiency of the bottleneck step or decrease input to the bottleneck step. So basically, we reduce the amount of items that's coming to that area so it can catch up with the production, or we can increase the efficiency of that process to be able to handle all these coming inputs. So those are the basic solutions for unblocking bottlenecks. By this, or by this slide, actually we will be done with this chapter. If you have any questions, please let me know. That will be all for this session. Thank you and have a great day.